So, Kevin, Peter, thank you for joining me here. I have Kevin and Peter from Capgemini. Super excited for you to join me to have a conversation about many of the things we're seeing, but particularly what we're seeing in the world of robotics. So maybe I'll start there.
Great.
In the world we're seeing of robotics today, we've been through a time where robotics were more sort of time deterministic, they were performance deterministic, they were set up to do very sort of specific functions. Now, with the increasing levels of AI deployment, robots are becoming more adaptive, more responsive to their environment, and the pace seems to be increasing.
Yes.
Some of us will describe that as physical AI.
Sure.
When you meet customers today, Capgemini's customers, and they ask you, hey, do you think I'm ready for physical AI deployment in my factory floor? What do you say to them in 2026?
Usually no. Are you ready? But we can help you get ready, right? That the idea of coming in and looking at those deterministic systems and figuring out how AI and physical AI can help them and in which way we can help them from hardware all the way through to the software ecosystem. It's a huge experience for us all as we're learning and growing as the market is changing.
Right, yeah. I think, as you said, John, physical AI, embodied AI, that's a topic that's not only on the agenda of the boardroom, but it's also on the agenda of the factory floor, and that makes it exciting. And as I said, it's a multifaceted problem, yeah? So it's not only how you organize your workflow, which tasks do you give to the robots, what can they do now, but also, as I said, the pace of innovation is breathtaking, yeah? Also what is possible in 6 or 12 months, yeah? Yes. But also how you integrate these electronic systems in your overall flow, right? And as we see, it's not only about the mechanics of the robots that are evolving fast, but the real key is in the intelligence, yes, right? And in the power of the embedded systems. And this is a playing field that is super attractive, and it gets really shaped now. Yeah,
I agree with you. So let's pick up on that point again then, because Intel has had a role in the control side of robotics for a long time. Actually, it's a pretty established business. But when you bring AI into the equation, look, there's a natural sort of affinity to maybe move to alternate architectures. In a lot of cases, the developer will think naturally, maybe this is how I solve for that problem. There's an environment, there's a software environment I'm familiar with, and a lot of it revolves around NVIDIA.
Yes.
Now, I know you guys took the challenge on that and said, hey, what if we looked at what the Core Ultra Series 3 product can provide, our processor, versus that alternate? And you found some pretty exciting things. But firstly, what motivated you to do the benchmark comparison between the two?
Oh, vendor lock-in, right, is a huge issue in the world right now. And taking on different architectures and understanding them helps us deliver new products to clients. That's number one, right? But number two is looking at the Intel stack, not only the hardware, but the software and how it allows the mind share, as Peter says, for engineers and developers to come up to speed quickly from the OpenVINO platform to One API, to the RVC, robotic vision control, and the robotic stacks that you're creating. It makes it quite simple. The documentation is fantastic. So it's one of these things where you've lowered the barrier to entry, and getting up to speed quicker is really, really important. And then when you look at the benchmarking, it outperforms all of these other architectures. So it's things that we've been reading about for the last year or more. When is Panther Lake coming, right? We really think this is going to be great. Will it be great? And then it comes out and it is great. We can do vision language now at the edge. We do all of our AI inferencing at the edge, right? We don't need two systems. We can do this all with one system. Smaller, less heat, less expensive. It's just a fantastic endeavor. I'm so happy to be partnering with you on this.
Yeah, that's really great to hear. So as I think about what you're describing then, this ability to bring that functionality closer to the edge. When we conceived the product, the Core Ultra Series 3, the former Panther Lake product, we thought about it on the vector of saying there are 3 compute subsystems. CPU to do the real time, to do the control function, the more natural things we would have traditionally done. Then the XE graphics engine to provide for larger model support, VLM support on the device, and then the NPU in addition to say, hey, you need a very efficient engine for the neural network piece to allow you to perform that level of AI as well. And taken together, all 3 subsystems create a embedded system for the edge. So let me ask you a question then. Is physical AI on its current trajectory becoming an embedded system as opposed to a back-end large data center solution? What do you think?
I think that when we often talk about how AI will change our world, our society, yeah? And very often at the moment AI is confined in the discussions to the large data centers, the gigafactories, for number crunching, yeah? But that's only one part of the equation.
Yes.
Because we are convinced, yeah, that the real lever is when AI is run at the edge, at the devices close to the use case, close to the consumers, right? Or to the users, yeah? And this is the real playing field where it's exciting. And coming back to your question before, our role, Capgemini, right? We are one of the largest technology consultancies in the world, yeah? And our added value is to look out and consult our clients, what is the best technology that will shape the future? And in my opinion, it would be foolish not to put Intel on the radar, right? And this is our recommendation also for the boardrooms and for the technical users, yeah? As I said, it's a decade-long history, right, of reliable and high performance chips for embedded systems, right? And you have renewed your product line now, right? And as we say jokingly, the package you built out of the chip, the documentation, right? The accessibility, but also how it is supported through AI coding tools. That's important.
It's a joy to work with.
It's a joy for the developer, right? And I think this is super important to overcome. I think we discussed it earlier, this muscle memory, yeah? I've always used that solution. I know where the screwdriver goes and that's fine, yeah? And sometimes, as a seasoned engineer, you need to get over the hump to discover a new world of opportunities.
Yeah. If I take, maybe pick up on that point, Peter, is that, there's this natural affinity question you talked about. Like, as a developer, I have a direction I will take because it's my natural direction. So if we cast our sort of minds forward a couple of years, we say, what does the future entail?
Yeah.
Seems to me that the winning compute platform of choice will be the one that developers will naturally reach to, where they say, I'm building a physical AI solution. Irrespective of the market that they're trying to service, they'll say, this is where I need to go. Then I think about, well, how do you ensure that can occur in what is still a highly fragmented environment? The applications are diverse. The markets that served are wide and growing. The pace is increasing, right? What role openness plays there? I'm curious as to your thoughts on what role does open play in enabling that to be true?
Huge. Having an open platform, having the open source support from Intel for your platforms, it means not only quick adoption, it also means that new systems are going to support that. So for example, Ubuntu 24.04, everything's supported. Ubuntu 26.04 coming soon will be supported, right? Those were always problems in the past, right? With your support behind those libraries, it's a game changer. It really is. But to get back to that original question about physical AI, and I see physical AI as just another term for embedded computing. Right. You had the industrial age, right, and then the information age, and we had embedded computing in between those two, and now the marrying of those two for physical AI, it may not be called physical AI next year. It may just be embedded engineering, because all of our embedded systems in engineering needs to come up to speed on AI and using it, and the Intel platform allows us to do that quite simply.
Yeah, absolutely. And I think just to add to that, yeah, for me the key winning factor, so that the product is great. So I think this is a given with Intel, yeah. So, but also how accessible it is, right? Can people already at an early stage can try it, play with it, and discover that world of opportunities. And I think openness or open standards, right? It's a key lever to make that happen. And I'm very happy to see also in our benchmark, in our programs, what we run with Intel, yeah, that there was a big change, a big shift, yeah. So it's much more easy to get into, and also that speed until the first implementation. That was something what we really liked about the latest platform and the package Intel built, right? It's much more faster to prototype, to implement, and have something that is nearly production ready in no time. And I think that is a game changer.
And we should also mention, I haven't mentioned yet, Intel Getty for computer vision. Right. The first time I used that product, installation to deployment of the model was about an hour. An hour. I mean, that installation, installing the tool, Intel Getty Action, which just came out about a week ago, is very similar to do imitation learning. So the tools are there, the support is there. It's a monumental shift.
Right, yeah. I think that's important, that not only AI, as said again, in the end product, so this is what you're building, what you're enabling, but also the AI support in the development and project engineering phase. I think that's good, and it's very promising from our point of view.
Yeah, it's really exciting to hear. And the work we do together is so exciting to ensure that we're enabling that fast time to implementation for the market at large. And I think it's really key to it. Last question before I leave you guys go. If you were giving advice to somebody who's embarking on a physical AI program or project today, what might be the top of mind things you'd say, you must consider this, or this is something that you don't want to omit? What would that be?
Long-term cost, right? Long-term availability of products, right? Making sure that the architecture you choose is there in 5 years, it's there in 10 years. these systems that we're putting in place, they're not going to go away in a year. You're going to be running it on your line, in your warehouse, et cetera, 4, 5, 7 years.
Right.
And we want to make sure that that support is behind that. And we know that it is at Intel.
Right. I think it's cost long-term support, I agree. But for me, it's something even closer, yeah, and be ready, willing, and able to open up your mind and look for alternative solutions than what you have done the past 5 to 10 years.
Love it.
Because we are entering a new era,
Yes.
and a lot of providers, right, yeah, have changed their product portfolio significantly. So did Intel, right? And you need to evaluate the new available options. And I think this is key for a manager to push his development team in that direction, yeah, to really evaluate what all the players have. Yeah? And then you will think, at least from my opinion, that Intel is a winning formula for many use cases.
Great. Peter, on that point, we'll leave it. I appreciate both of you for spending time with us. Thank you for all
Thanks
the
for having
insights and for the ongoing partnering.
Excellent.
Thank you very much, John. Thank you. Thanks for having us.